Good morning once again. Hello, I'm here, your teacher in Mathematics 9. Again, I'm Gemma P. Coronel, teacher in G9 Mathematics. Okay? Our lesson for today is about quadratic inequalities. We have here, when we say equalities, we are dealing with greater than, less than, greater than or equal, or less than or equal. Now, to start with, the objectives is illustrate quadratic inequalities and solve quadratic inequalities. I have to deliver this lesson as simple as this. Okay? Now, the first thing we do is we have to define the quadratic inequalities. And what is the quadratic inequalities? A quadratic inequalities is one variable is an inequality that contains polynomials whose highest exponent is 2. The general forms are the following, where A, B, and C are real number, with A is greater than 0, and A should not equal to 0 or not equal to 0. What are the different quadratic inequalities? We have for the first one, ax squared plus bx plus c is greater than 0. Another, we have ax squared plus bx plus c is less than 0. Another one, we have ax squared plus bx plus c is less than or equal to 0. And the last one, we have ax squared plus bx plus c is greater than or equal to 0. Those are the 4 quadratic inequalities. Now, you have to memorize those quadratic inequalities. Now, in solving quadratic inequalities, we need to find its solution set. And what is this solution set? The solution set of quadratic inequalities can be written as a set and can be illustrated through a number line. Okay, again, the solution set of a quadratic inequality can be written as a set and can be illustrated through a number line. Now, to illustrate the solution set on the number line, we need to consider the inequality symbol used in a given quadratic inequality. For number 1, we have here, example, this is the value of x, where x is greater than -2. And what is this -2? Now, this -2 is known as the critical point, wherein the value of x is greater than -2. Again, we have to analyze first the number line. Since this is a number line, of course, it is a number with it is a line with a number. Again, from 0 to right is a positive number. We have, and then from 0 to left are the negative number. Now, take note that all number on the right side is greater than the number on the left side. Okay, 3 is greater than 2. 2 is greater than 1. 1 is greater than 0. 0 is greater than -1. -1 is greater than -2. -2 is greater than -3. Vice versa, -3 is less than -2. -2 is less than -1. The same holds true with -1 is less than 0. Okay? Now, let us go with the graph. Now, -2. Immediately above -2, we have to put a symbol. This one is known as a hollow circle. Why is it a hollow circle? We have to use a hollow circle because of the greater than or less than. If the symbol is greater than or less than, we have to use a hollow circle. -2 is not included in the solution set, but immediately after -2, that is already included in the solution set. All the number greater than -2, from -2 up to positive infinity, belong to the solution of x greater than -2. Again, the boundary is -2. Immediately after the -2, all the numbers on the right side of a number line belong in the solution set. Again, how about number 2? X is less than 0. Again, 0 is a boundary. Immediately above 0, we have to place a symbol. Since it is less than, 0 is not included in the solution set. But immediately after 0, to the left side of a number line are a solution set of x less than 0, because all those numbers are less than 0. Okay? Next. For number 3, if x is greater than or equal to -2, since the given inequality is greater than or equal, we have to use a solid circle. Immediately above -2 is a solid circle. Again, all the numbers, the same holds true with number 1, all the numbers immediately after -2 to the right are greater than -2. Those are the possible value of x. Those are the possible value of x up to the positive infinity. Number 4, x is less than or equal to -1. The boundary is -1. Since the given inequality is less than or equal to -1, again, the boundary is -1. The symbol is a solid circle above -1. All the numbers immediately after -1 to the left are the possible solution, okay, of x after the negative infinity. Okay, all the real numbers, set of real number, okay, less than -1. Now, again, we have the symbol for greater than and less than. We have to use a hollow circle. This means that the critical points are not included. For the greater than and equal and less than and equal, because of the symbol equal, we have to use a solid circle. The critical points are included in the solution set. Okay? Now, example number 1, find the solution set of x squared plus 3x plus 2 is greater than 0. Again, we have x squared plus 3x plus 2 is greater than 0. The first thing we do is we have to transform the given quadratic inequality to quadratic equation. in order to find the value of x. X squared plus 3x plus 2 is equal to 0. Then we have to find the value of x. Again, we have the four ways in finding the value of x or the solution using factoring, extracting the square root, completing the square, and quadratic formula. But you have to use the easiest way, okay, in order to find the value of x. This one, we can able to find the value of x using factoring. The factor of x squared is equal to x times x. The factor of 2 is 2 times 1. But you have to check. The middle term is 3. See to it that the middle term is equal to 3 using FOIL method. Let us check. 2 times x is equal to 2x. X times 1 is equal to x. 2x plus x is equal to 2x. Therefore, our factor is correct. Then, equate to 0. X plus 2 is equal to 0. X now is equal to negative 2. On the other side, x plus 1 is equal to 0. X is equal to negative 1. We have two values of x. The first one is negative 2 and the other one is negative 1. Those are the critical point. Okay, the critical point. Now, negative 2 or negative 1 serve as the boundary or the critical point. Boundary of the graph. These points divides the number line into 3 parts. The left side of a number line, okay, the numbers between negative 1 and negative 2, and the numbers immediately after negative 1 to the right. Or it divides the number line into the 3 regions. This part, immediately negative 2 to the left, between negative 1 and negative 2, and immediately after the negative 1. Okay, now this is the solution, but we have to prove if this is correct. You have to check, you have to assign value of x in order to check if this is the solution. Let us see. If x is equal to 3, let us check if x is equal to 3. Okay, substitute to the given quadratic inequality. If x is equal to negative 3, x squared plus 3x plus 2 is greater than 0. Substitute the negative 3. Negative 3 squared is equal to 9 plus 3 times negative 3 is negative 9 plus 2 is greater than 0. 9 minus 9 is 0. Plus 2 is equal to 0. Therefore, 2 is greater than 0. 2 is greater than 0, and that is true. That's why the graph immediately after negative 2 are the solution set for the given inequality. X squared plus 3x plus 2 is greater than 0. Now, let us check a number between negative 1 and negative 2. Let us assign number between negative 1. You can use negative 1.1, negative 1.2, negative 1.3, but we have to choose the middle number, negative 1.5. For x is equal to negative 1.5 if it is included in the solution set. Okay? If x is equal to negative 1.5, x squared plus 3x plus 2 is greater than 0. Substitute negative 1.5 squared plus 3 times negative 1.5 plus 2 is greater than 0. Negative 1.5 squared is equal to 2.25. Positive times negative is equal to negative 3 times negative 1.5 is equal to 4.5 plus 2 is greater than 0. Again, you have to combine 2.25 plus 2 because they are both negative. That is 4.25 minus 4 negative 4.5 is greater than 0. The answer is negative 0.25. Is 0 negative 0.25 is greater than 0? It is false. Yes, negative number is always less than 0. But here, negative 0.25 is greater than 0. It is false. Okay, let us check the graph if that is correct. That's why. Okay, now from negative 1 and negative 2 is not included in the solutions, in the solution set of the quadratic inequality. How about the number immediately after negative 1 to the right? Let us choose a number to test if that is correct. Let us choose if x is equal to 0. Okay. If x is equal to 0, x squared plus 3x plus 2 is greater than 0. Substitute the value 0. 0 squared is equal to 0. Plus 3 times 0 is equal to 0. Plus 2 is greater than 0. What is left now? 2 is greater than 0. Yes, 2 is greater than 0. And that is true. This is now the solution set. X such that x is less than negative 2 and x is greater than negative 1. Let us again take a look with the graph. Now this is a graph. This is the value of x now. X here is less than negative 2, while the x here on the right side of the number line, x is greater than negative 1. This one is x is less than negative 2. Is that clear? Okay, now example number 2. Example number 2, we have x squared minus 3x is less than or equal to 10. Now, the inequality is less than or equal. We have to use a solid circle. The first thing we do is we have to arrange the given inequality into standard form. X squared minus 3x minus 10 is less than or equal to 0. And then transform into quadratic equation, that is x squared minus 3x minus 10 is equal to 0. Then factor. The factor of x squared is x times x. The factor of negative 10 is negative 5 and positive 2. But you have to place negative 5, negative in negative 5 because of the middle term. See to it that the middle term is negative 3. Let us check. Negative 5 times x is negative 5x. X times 2 is equal to 2x. Negative 5x plus 2x is equal to negative 3x. Okay? Then equate to 0. X now is equal to 5. And the other one, x is equal to negative 2. Negative 2 and 5 are the critical points or the boundary. Okay, immediately above -2, we have to place a solid circle. The same will hold true with positive pi. Immediately above positive pi, we have to place a solid circle. Then test the value on the left side of -2, the number between -2 and 5, and the number immediately after positive 5 to the right, because the critical points divides the graph into 3 regions. Okay. To test, if x is -3, let us check. If x is equal to -3, x squared minus 3x is less than or equal to 10. -3 squared minus 3 times -3 is less than or equal to 10. -3 squared is 9. Negative times negative is positive. 3 times 3 is also 9. Less than or equal to 10. 9 plus 9 is 18. 18 is less than or equal to 10. That is false. Okay? That is false. Let us take a look with the graph again. That's why immediately after -2 to the left are not a solution set of the quadratic inequality x squared minus 3x less than or equal to 10. How about the values between -2 and 5? Let us assign value. Any value, -1, 0, 1, 2, 3, 4 can be. Okay, let us use 0 if x is equal to 0. If x is equal to 0, we have to substitute to the quadratic inequality. X squared minus 3x is less than or equal to 10. 0 squared minus 3 times 0 less than or equal to 10. Obviously, 0 squared is 0. -3 times 0 is 0. Is less than or equal to 10. 0 is less than or equal to 10. That is true. Okay, again, look at the graph. We have here, that is the solution of the given inequality, where x is greater than -2. Let us test a number immediately after positive 5 to the right, to the right. Let us say x is equal to 6. Okay? If x is equal to 6, x squared minus 3x is less than or equal to 10. X squared, 6 squared minus 3 times 6 less than or equal to 10. 6 squared is equal to 36 minus 3 times 6 is 18 less than or equal to 0. 36 minus 18 is equal to 18. 18 is less than or equal to 0. That is false. This is the set builder notation where x such that x is greater than or equal to -1 but less than or equal to 5. Okay? Let us look at the graph again. Now, from here to that point are the value of x. This is the value of x. Okay, where x is greater than -2, but it is less than 5. Okay. This one is the final answer. Now, this is the activity. Illustrate and find the solution set of the following quadratic inequalities. Number 1, x squared plus 7x plus 12 is greater than 0. Number 2, we have 2x squared minus 5x is less than or equal to 3. Number 3, 2x squared minus 5x plus 1 is greater than 0. Okay, that is the end of my lesson. Okay, thank you again and see you next meeting.